raised I'm going to be.
Well, good evening, everyone. Welcome to the weekly HRTV show. Tonight we're taking Nerd to 11. That's right, I got my BCGs on. I don't know how many of you know what that is or meant, but let me know if you know or had some BCGs. But yeah, we are here again in the, what are we calling this place? The HRTV studio. I've got some cool buttons to push. I can not show you that because the camera's not on.
Well, we'll call it the Ham Radio TV Lab. How's that?
All right,
or the Ham Radio TV Workshop. Now that we
you don't get a second chance when when we're live.
Yeah, it's live and we're making stuff up as we go. I mean, you know, who knew? We took a break and the camera went to sleep. Holy cow!
All right, so what do we got going on tonight? Tonight we've got radios, oscilloscopes, and a service monitor. Now, some of you might not have heard or seen a service monitor, but they're a pretty big deal when it comes to radios, repeaters, and really getting in there and seeing things, to visualize. And so what we're going to do is we're going to take these radios and we're going to use some frequencies and we're going to be able to look and listen the different audio bandwidth. Some of the stuff we were talking about last week was more microphones. This week is going to be more the radios. So I'm going to kick it over to Kevin to start us off.
Well, thanks, Jason. Well, tonight we're just going to be just kind of having a little casual evening here in the Ham Radio TV workshop. And we're going to be talking a little bit about the frequencies, the audio frequencies that pass through your radio. So what I'm going to do right now is, Jason, if you could switch over to the Kenwood radio cam right here. So there's the Kenwood radio cam. And if you look on top of the Kenwood radio, there's also an Alinco radio. The Alinco is the 570, and it's a 2-meter 440 radio, commonly known as a dual band. And underneath it here is the Kenwood TS450S, and this is a HF transceiver. And both of these radios are old. Both of them are in excess of 20 years. Yeah, go ahead, Jason. We're going to pause for a moment to let Mr. Producer laugh. Go ahead. Ha-ha.
Well, yeah, I forgot my mic was on. Back to you.
That's okay. You know what? I like it when Mr. Producer has a hot microphone because, it picks up all his cool comments. Anyways, back to the task at hand. This is a Kenwood TS450, as I already mentioned, and it's an older radio. It's at least 20 years old, and the radio on top of it is also at least 20 years old. The reason we did it is we just pulled these radios out of the shop. We've used them for field days, loaner radios, test radios, just a different assortment of things. And I didn't want to use a really modern radio that had all the super duper bells and whistles. So I want to start this off with telling everybody that yes, there are newer radios that have better filters, better electronics, better audio, but you pay more money for them. And some of the newer radios, such as the ICOM 7300, if you're looking at specifications, its high frequency response rolls off very sharply at 3 kilohertz. And some of the SDR radios out there are adjustable above and beyond 3 kilohertz. And one of these days, we'll get a couple of those radios in here and an SDR radio, and we'll hook it up, and we'll show you what some of those filters do and how you can expand your audio transmit bandwidth and your audio receive bandwidth. But for today's demonstration, we're going to stick with the old faithful stuff from 15, 20 years ago, and they are set as the factory manufactured them. They're not modified. We didn't do anything to these, so what we see is what you get. So what we're going to do is start out, and I'll slow down a little bit. We'll start out with the Kenwood, and you notice it's set at 7 megahertz. 7 megahertz. We also have it set on upper sideband because we're going to be testing in the sideband mode. Right here on the bottom corner, left-hand corner where I'm trying to point, is where the microphone jack is. Well, that's where this connector here is going to, the signal is going to come in from my trusty Heathkit IG18 signal generator, which I really love that thing, and we'll talk about those type of generators in the future. But for tonight, we're using the IG18 as our signal source. This is a homemade push-to-talk switch. That's pretty obvious by the wire that's going up here. And
That's fancy.
Isn't this? This is so sexy. Yeah, Heil. Yeah, eat your heart out, Heil. Look at that. So anyways, not really. Bob Heil makes a beautiful switch. This is just a dumb one we made. So that way, when I push the switch with my thumb, and if you take a look at the display, you'll see it. It'll change. It's going into transmit mode. So we're using that as a tool to inject the audio into this 8-pin jack and trigger the audio. So now let's move up to the spectrum analyzer display, or I should say the communications monitor display. Can we do that, Jason? Can we swap it? Look at that. Jason, if you hear me refer to Jason as Mr. Producer, because he is. He is the producer of Ham Radio TV, and we appreciate all his efforts. So let's move on. So take a look at the screen, everybody. At the top of it, it's pretty obvious. It says TX test. It's transmit test. And what I want you to take special attention to here in the beginning is up on the left-hand side, upper left corner, it says transmit frequency error. And we'll get back to that in a moment. Right below it, it says transmit power, and that's measured in watts. And the other item we're going to look at is to the right. And the right, you'll see it where it says AF frequency in kilohertz. And we can make that hertz or kilohertz, but we've chosen kilohertz. And ultimately, if our input frequency matches the output frequency, everything's working correctly. So if this thing is working right, the transmit frequency error should be equal to the input frequency. So looking at the screen, you'll see on the far left-hand side in the middle, you'll see tune frequency. It's set at 7 megahertz. That's the same 7 megahertz we set on the Kenwood, our center frequency. Look in the middle of the screen, you'll see where it says SSB demod. That means we've set the analyzer to demodulate our single sideband signal. So we'll get to use our spectrum analyzer, our service monitor, as a receiver that can give us a visual display. So some of you might be saying, well, the transmit error, that usually means that you're off frequency. Well, in this case, what we're doing is we're going to assume that the radio is reasonably aligned well, and it is. It's not perfect, but it's really pretty close. Our center frequency is 7 megahertz. But if everything's working right, when we put an audio frequency into the microphone, that audio frequency will be represented in the form of RF on the output of the radio. So if I put in a 2 kilohertz tone, I should get an RF output that's 2 kilohertz higher than 7 megs because we're using upper sideband. And there's another visual I'll show you in just a moment to help you wrap your head around how upper sideband it goes up and lower sideband it goes down. But for today's demonstration, we'll be using upper sideband. So now what I'm going to do is I'm going to key the radio. And as you noticed, the unit went into transmit, and we're looking at our transmit frequency and our receive frequency and our AF frequency are the same. Now I'm turning up the audio on my receiver. I hope you can hear that. That's really close to 2 kilohertz. We're seeing our output is 1.990 kilohertz. Now that could very well easily be my generator could be off just a tad. And it's really, really close. It's toggling back and forth. So that is 2 kilohertz. And the transmit error, which is actually our output frequency, is matching the input frequency. And you'll notice that we have transmit power in watts because we're putting the audio into it and it's driving the single sideband circuitry to give us the RF out. If I take away the audio completely, it will stop. So what I could do is I'll unplug the audio from the signal generator. Now I'm keying the radio right now. Nothing. It's looking for something. There's nothing there. I'm not putting anything into it. Now I plug it back in to my Heathkit generator. There we are, 2 kilohertz, and I'm putting out approximately 6.8. We'll call that right on the edge of 7 watts. Okay? So we're talking about audio bandwidth. We just had a brief review of what we're looking at. So now let's adjust the frequency. I'm going to turn the tone down a little bit so it's not quite so annoying. But last week we talked about audio frequencies that can pass through your single sideband transmitter. And different transmitters will behave differently from brand to brand and the type of filters that they've put into your transmitter. So what we're going to do now is key the radio, and we're going to look at the RF output, the transmit power, and change the frequency and see what happens. Okay? So I'm going to key it, and I'm going to turn the volume up. Hope you can hear that. So now I'm going to go to 1 kilohertz. Okay? Now I'm going to bring it back to 2 kilohertz. And now what I'm going to do is I'm going to take it and I'm going to start turning the other knob and bringing it up approximately 100 hertz. I'm up to 24, 25, and notice the power output. Let me bring it back to 2 kilohertz. See, I'm back to my 6, almost 7 watts. Now I'm going to creep back up in frequency. I'm at 24, 25, 26, 27, 28, 29, 3,000. 3,000, I've brought my energy way down, way down. So what is that really telling us? That's telling us that our upper frequency bandwidth starts severely rolling off for the audio spectrum well before 3 kilohertz. And then we got to ask ourselves, okay, what if we crank on that treble control or high frequency control? I'm going to try and squeeze a little more high frequency out. Well, you will up to 3 kilohertz, but let's do this. Let's turn it back on and let's go to 3 kilohertz. Look at that. We dropped our power down to almost nothing. Now let's go to 4 kilohertz. I am injecting 4 kilohertz and I'm putting out no power. My radio is now unkeyed. Now my radio is keyed. There's nothing there. My radio is still keyed. Now I'm going to go back to 3,000 hertz. There's a little bit of energy there. Now I'm going to go back to 2,000 hertz. Oh, there we go. Back to our 7 watts, give or take. And there's our 2 kilohertz tone. So really what we've done is we've looked at the low pass of what the radio will do. Now, it's a little more difficult. We can take it down lower in frequency if we would like to. So now I'm going to just for fun, I've taken it down to right around 500 hertz. A little bit lower, and just below 400, just below 300, just below 200. Look at that. When I drop below 200, it really starts to dive. Now I'm at 100 hertz. Actually, I'm really, really low. That's 100 hertz right there. So it's a little difficult to imagine that in your head, you know, what that looks like. So let's do this. Let's take the device and let's look at the communication screen, and we're going to go to a different view. Okay? Just want to test it, make sure it's working right. Okay, so we're going to kind of do the same thing. But what's happening here is it's a different kind of display. We're still at 7 megahertz is our center frequency. And if you look at the bottom right hand where it says span, it says 10 kilohertz. And what that means is that each one of those vertical lines represents 1 kilohertz spacing, or 1,000 hertz. So if this thing's working right, I set the generator back up to 2,000 hertz. I left my power, everything else pretty much the same. And I'm going to key the radio, and it should be 2 lines to the right. It should show us visually where 2 kilohertz winds up. Let's key the radio. And lo and behold, we're dead on. We're 2 lines, or 2 kilohertz. I'm going to put it in between so you can see it. And what I'm doing now, I turn the output of the generator down a little bit, and that literally changed my power level. Okay? Because how much audio I'm driving the radio with is directly proportional to how much energy it's putting out. Because your audio is your RF. And we can talk about that in more detail later. But at this point, we're seeing a 2 kilohertz signal, and it's showing 2 kilohertz to the right. So we're on upper sideband. So we're 2 kilohertz above 7 megacycles. So if I turn the frequency knob on the Heathkit down to 1 kilohertz, now I'm showing 1 line, which is 1,000 hertz. So now, and you're noticing between these two, they change a little bit. 1,000 is a little bit stronger than 2,000. And that's most likely the filter in the radio. I'm going to unkey the radio now, and I'm going to go to 500 hertz. And if all things being correct and equal, it should be halfway between the center frequency, 7 megahertz, and the first line of 1 kilohertz. And there we go. It's right there. So now if I start, you might not be able to hear it. My speaker in the receiver is quite small. So the lower in frequency it goes, the harder it is to hear. Okay? I'm turning the power down. I'm keeping the power on the radio really low. So now I'm going to go down here. There's 400 hertz. There's 300 hertz. There's 200 hertz. There's 100 hertz. And you can look to the right. It's still there. It's working. And if I get up here, there's 100. And I'm going down, down. I'm getting to the point where there's almost no energy. I'm at 50 hertz right now. So let's do this. To be fair, let's go back to look at our power output. Like I said, we're completely at the mercy of what the filters of this radio are going to do for us. So I'm putting that 50 hertz in. I mean, it's almost not even responding because it's just so low. So I'm at 50. I'm creeping up, creeping up, creeping up. There we go. I finally got it to start showing 0.07 watts. Well, let's do something. Let's bring it back to something reasonable, like 200 hertz, 300, 400, 500. And I did turn the power down, folks. I brought it down. I'll bring it back up to 7 watts. I just didn't want the radio to get hot when I'm holding the key down an extended period of time. But I'll bring the audio up where we're closer to our original 7. That's really close. So now I'm going to bring it down to 300. There's 200. There's 2.1 watts. Look at that. That's 100 hertz. So I'm going to put it back to 500. And we'll go back to the other display. So what we're looking at here is a 500 hertz tone. And we'll just watch it step up. 6, 7, 8, 9. There's 1,000. and we whip it back down to here, and we start at 1,000. Actually, that's 2,000. Because I left the knob turned all the way over there. And then we're going to take it to 1,000. Just walk it up. And now we'll start at 2,000. And we'll start walking it up. And this is the display that's real easy to see how the filters on the radio just eventually roll it off and go to 4 kilohertz. It's just gone. So that's a real quick example on the HF radio of what it visually looks like to get an idea of what the audio spectrum is doing. Your radio takes your audio energy, converts it into RF energy, and then on a sideband radio, on upper sideband, it's taking that particular frequency and converting your voice into RF energy. So if your voice, the meat of it is, like my voice is low, there's a lot of energy in the lower part of the spectrum. As a matter of fact, we can unplug this and we can just plug this is just a standard off-the-shelf Kenwood microphone that comes with it. And what I'll do is turn this volume down. 1, 2, 1, 2, 1, 2. So I'm going to key the radio again, just talking to it, and you'll see the majority of my voice is in the lower part of the spectrum. It's not a whole lot of energy around 3K. 1, 2, 1, 2, 3. So it's rolling off very similar to what it did. But if I was to do my semi-famous in my zip code white noise, shh, there you go. That kind of gave you an indication of what the audio is coming out of this radio based on this microphone and the filters in this radio. And if I plugged a much more narrow band mic in, it would be even narrower. And if I was able to whistle, and I can't whistle very well, you'll see the tones moving across the screen just like the signal generator did. Now I'm going to unkey the radio. So that's a real quick demo there on the HF radio. So now what we're going to do is we're going to switch over to our handy dandy Alinco 570, and we're going to do the same thing, and we're going to see, and hear where the audio range is usable. And I'm listening to it we'll be listening to it on an external speaker, not a little 3-inch speaker. We have our handy dandy 4-inch Radio Shack communication speaker, the best one ever. Hi. So probably more like an average speaker that most ham radio guys would get their hands on. So we're going to use that, and we're going to use the same signal generator, and we'll start off with the we'll be using the oscilloscope to take a look at the output of the radio. So here's what we're going to do. It's going to take me just a moment to convert the connections over.
And I'm still here.
And Jason, Mr. Producer, yes, can you...
And I told you there is a reason why I put these glasses on, because we are definitely nerding out quite a bit. But how fun is this to see all this equipment work? It's not every day you either have the equipment or know someone with it, and then you got to kind of know how to use it. So anyways, this is really good stuff. And, I also wanted to let people know, I think some people have already discovered this, the cat is out of the bag, but we are building a website. And once you know, when you want to do a little making and selling, you need to get a tax code. So anyways, that's under construction right now. But I'll let you know where it is. It's HRTVshop.com. That's kind of what we're going to be putting out there in a little bit, HRTVshop.com. And I did create an email. And what's funny about email is you got to use the right type of email and the right name. Otherwise, it goes right into a spam box. So I kind of came up with one. The email goes to both Kevin and I. So feel free to email us if you got any questions or if you're inquiring about things in the store before it goes public. And the email, pretty easy. It's just Elmer, Elmer, Elmer at HRTVshop.com. And that's kind of what we're building out. We're going to have some cool stuff there soon as Kevin is plugging away over there.
We're almost ready. I had to switch stuff over. I'm really not that cool, so we're gonna get this switched over here.
And I am watching the chat. Hello, Andy and Mike and Fred. I feel like you have to sing Fred's name. If you're familiar with the K6POU repeater, that is the way Fred introduces himself and others. And Mike and Greg. I see Ben and Bobby, Alex.
Man,
a whole lot
of folks.
What's funny is I really enjoy, I've been kind of doing this streaming thing for, it's coming up on a year, and it's a lot of fun seeing some familiar names. I start learning your little profile pictures, it just kind of catches my eye. And yeah, it's fun. It's almost like we're building out. And there's Paul, of course. I talk to Paul at 5:30 in the morning when I'm in my car. Yeah, it's really neat, kind of creating this little group. And I think you guys like it. We're going to be all over the place for different subjects and topics, but this kind of builds on our audio thought process and stream of things. If you do like it, you could hit the like button or the dislike, whatever.
No, only hit the like button.
But that'll let me know if you're still breathing with a pulse. How is things going over there?
We are almost ready. I
can bring that shot in. Yeah, Kevin gave me this controller. I've been using it a little bit. This little controller can move things around. Look at that. I can go that way. Now, you get the picture.
All right, man. We are like getting some cool stuff going on here.
All right. So you ready?
Yeah, I think so. Let's get back over here.
Back over to you.
Let's get back over here. So now what we've done is we've taken the Alinco radio and using our same handy dandy Heathkit generator, which I already told you I really like this thing. It's really clean. And what we're going to do is we're going to just put the tone in to the radio, and we're just going to look at the scope and see what we can. Let me rephrase that. We're going to look at the scope and see how high and how low we can go with the frequency. Okay, so at the moment we're on spec hand, but I'm going to move it over here to scope, and let me see if I can't get it to work right. And that's really high. And let's see, it's not. Oh, that's because we don't want it on single sideband. We want it on FM demodulate. Jeez. Yeah, that's right. There we go. It got confused. That's really high. It's 3,000. It's hard to hear on my test bench. Okay, so now what we're doing is we're looking at the we're looking at the antenna output, the RF output of this radio, and the analyzer is just demodulating it, and it's showing us, and it's pretty wide band, so it's showing us what we can expect to get out of it. So if I put 2 kilohertz in, and there's 2 kilohertz, and you see it's filling up basically vertically 2 squares, okay? And I'm going to increase the frequency, and I went to 3 kilohertz, and it didn't hardly change. And I went to 4 kilohertz, whoop, there we go. it's going down at 4 kilohertz, and there's 5 kilohertz, and there's 6 kilohertz, and there's 7 kilohertz, and there's 8 kilohertz, and I've unkeyed the radio. So the radio is putting out a carrier about 4 watts, but there's basically nothing there. You wouldn't be able to hear that. And we pull it back. Now there's 4 kilohertz. If your speaker was able to represent 4 kilohertz, you'd hear it. There's 5 kilohertz. If your speaker was able to do it, you'd hear it. But as we go lower in frequency, look at 3 I mean, it just shoots way up there to 3 kilohertz. It's 2 kilohertz. It's great. 1 kilohertz is great. And let's do 5. Come on. Well, there we go. There's 500, 600, 700. There's 1 kilohertz. So once you get lower in frequency, this radio, it starts, there's 500, and or 5,000. I have to read the numbers right. There's 2,000. So the meat of this radio, and there's 100 right there. You can almost hear that. It's doing 100 hertz pretty good. And there's a little more energy, so we can hear it a little better. And that's pretty dang good for 100 hertz. Let's come over here and let's try. There's 700, 800, 900. So this radio really starts to drop off much below 200 hertz. It's just really starting to drop off. So that gives you an idea of what this radio will do. Now that doesn't mean that newer radios won't do better. So let's take a look at this. So there's a 2 kilohertz signal. There's 3. There's 4. There's 5. There's 6. Yeah, it's starting to go away. 7. I mean, there's information there, but it's just not too usable. So this picture's a little bit different than the other one. And what we can do now is we can ascertain that this radio here has a wider bandwidth. I mean, right, it took us to 4 kilohertz, no problem. And it took us down to 100 hertz, no problem. And I can tell you that this radio, it doesn't do well below 100 hertz for listening for the audio, or for listening on the audio for that matter. It does pass the PL tones pretty well, but you got to modulate the PL tones at about 400 or 500 hertz. So what we could do now is we can take this out, because we don't want to accidentally key into the service monitor. And we're going to just unplug this plug, and we're still going to be at 146 megahertz. And just for fun, we got a little more time here. We're going to come up here, and we're going to go to this port here. And we're going to go to the RF generator. Now we're going to listen to our receiver. We're going to talk about the PL a little bit on here. Okay. So let's make sure we got on the right output port. So can we look at the radio for a second, Jason?
Radio.
Yeah, this radio right here. Yeah. So look at that radio right there. So now what I'm going to do is I'm going to come over here to my amplitude. Okay. And I'm going to put in a signal, a nice strong signal, about, S9, about minus 70, minus 72. You can toggle now. You can go over to the display. There we go. So now if you look on the display, you'll see we're at 146 megahertz. Our amplitude is minus 72, and that's really close to S9, but this radio is not calibrated so hot, so it reads the meter reads it's almost pegged. So now what I'm going to do is I'm going to put 1,000 hertz tone onto the generator, and I'm going to start, and I'm going to put it into the radio. So now I put 1,000 hertz tone into the radio. So now the generator is putting a 1 kilohertz tone into the radio. We're hearing it through the speaker. And if you flip over to the scope, Jason, he's my producer.
Wait a minute. Fire me.
Fire you.
Where are we going? We're going to you? You want the scope.
I want the scope.
Oh,
Yeah.
man. Okay, here
Let's
we
go to the scope. Well, I'll explain this when we're doing that. So what's going to happen is we're going to change the frequency, okay? We're going to leave it at about 2 kilohertz, deviation, which is plenty. And we're going to change it. And we're going to go down here and notice you almost can't hear that 100 hertz tone. And my volume is up. It's up quite a bit, actually. And my filters in the radio for continuous tone coded squelch or PL tones, it's all that stuff's turned off. So now I'm just putting a pure tone in there. And here at 200 hertz, you can see on the oscilloscope that at 200 hertz, I can hear it, and I got a pretty good signal level. And just for fun, here we'll hit auto reset on the super cool cheapo scope, and then we'll let it reset. Okay. And it's telling us we got about 480 to 500 millivolts peak to peak. Now I'm going to flip this up to 300. So my 300, I doubled my energy coming out, and I heard it get louder because the frequency response of the radio got better. So there's your 300 hertz. Now as we go up in frequency, you'll notice that here, and I'll reset it to make it a little easier to see. It'll show you. Look at that. It's got even more energy. It's going up. It's going up. It's going up. And now I'm at 700 hertz. So the radio is pretty efficient. So there I'm at 1,000 hertz, and it's varying. So we're looking at the response of the radio with a 8 ohm speaker on the output of it. And I'm actually measuring what's coming, what the speaker's measuring. The scope is in parallel with the speaker. So the capability of that speaker, okay, and the capability of this radio is what we're listening to, and it's what we're measuring, okay? So we're at 2.4 kilohertz, and that's pretty piercing, guys. So I'm going up 25, 26, 27, and now I'm knocking on the door. There's 3,000. And notice how much smaller on the scope it got. Much less level, and I'm starting to not hear it as much. Now I went to 3,100, 32, 33, and pretty soon I'm going to take it up to 4,000. I can still hear 4,000 on this radio. And now I'm going to take it up a little higher. I can still hear 5,000, but look at my energy level on the scope. It's almost gone. And now I'm up above 6,000, 6,200, 6,100. I can barely hear 6,000. So this radio has a pretty good frequency response. And notice in the meat of your voice from 300 to 2K, it's loud.
Hey, Kevin, you're not winning over any dogs right now at home watching.
We're not. Oh, here we'll turn it down.
No, it's fine. Kevin in the chat said, my pup is going nuts.
Your pup is going nuts. Oh, we're sorry. We're just trying to give everybody as close to a feel as they're here in the workbench with us so you can get an idea. Now what I'm going to do is we talked about the frequency response. So we're going to get something a little more pleasant. Let's go to a 400 hertz tone. We're going to bring that 400 hertz tone down to, I'm deviating at about 200. I'm not over. Now I'm really kicking it. I'm at 1 kilohertz deviation. I use something really small. So now what I'm going to do is I'm going to turn that tone off, okay? Now I'm going to move over to the other side of this other side of the generator. I hope you can see that up in the upper right-hand corner. I'm going to toggle it. You can see where I'm toggling AF generator 2. I'm going to use that as my PL code, my PL generator. I'm going to tell this radio right now, I'm going to go up here and I'm going to figure out, I'm going to hit function 127.3. Gee, I wonder whose that is. So now I have my CTCSS or my PL at 127.3. So what I'm going to do is come over here and I'm going to put my 400 hertz tone in there at 2 kilohertz. Got to turn the volume down, so that's going to be loud. Notice I don't hear it. Okay? And I want to change that to hertz. So I'm going to go 127.3. I'm going to dial it in. Okay? So that's my PL tone. Now I'm going to come down here. I'm going to turn it on. And I'm going to show you how that works. So right now, I am not getting the proper PL tone from my radio or my repeater or my service monitor. And now, and I have a 400 hertz tone going into it. So I want to hear that repeater, so I have to have a 127.3 tone. And we did use the word subaudible tone. It's not truly a subaudible tone. You're just typically on your ham radio aren't going to hear 127.3, and I'm going to demonstrate that on this gear in just a moment.
You're referring to last week's video.
Yes, I am.
Okay.
I used the word subaudible tone, and that's a real generic term. It's for radio, and because we typically don't hear that tone in the radio. But now what I'm going to do is I'm going to give it my PL tone, a 100 hertz. You know what? Let's make this easier. Let's go to, there's 100 hertz deviation, 200 hertz deviation. Let's see, yeah, this radio here likes a lot of PL tone. So it wants to see it'll hold the PL tone all the way down to 200, but there's 200 hertz deviation, 300, 400, 500. There it is. So if you're at a 600 deviation, you would hear it. Now, that's making it possible for me to hear the conversation. And the conversation's over here. You know, I got about 700 hertz going in there. And if you can see on the scope over here, the scope now has a 700 hertz tone and 127.3 hertz tone. The difference is the 700 hertz tone is being deviated or modulated at 2 kilohertz deviation, and the PL tone is only 600. And if I take that PL tone away, I will not be able to hear what's coming through my radio. I won't be able to hear the 700 hertz tone. So now what I'm going to do is I'm going to turn off the coded squelch. Now I'm hearing my 700 hertz because there's no PL tone required to do so. So now let's talk a little bit about, can we hear those PL tones? Well, let's find out. I have to turn the right knob. I'm going to turn this PL tone off. I misspoke. I'm going to turn off that 700 hertz. I'm going to come over here to this 127. The filter is turned off. The radio's just sitting here, and we're at a full scale on receiving, so we're way past the squelch. So now what I'm going to do is I'm just going to slowly turn up the deviation of that. And what I want you to do, if you can, let me see if we can see it. Okay. Way down there in the dirt. Okay.
The dirt.
Dirt, mud. Look at the scope. The scope is set at 20 millivolts per division, and we're getting, about 72, about 100 millivolts, give or take, peak to peak of that 127.3. Matter of fact, there's my frequency. It's 127. And this scope is not one of the better ones, but it's great for this demonstration. It's showing us that tone's really low. Now I've got my volume. Let me turn my volume up on my radio.
Oh, there it goes.
There we go. My volume is now all the way up on my radio. All the way. And that tone is deviating at 700 hertz. And the frequency is 127.3, which is a very common one. Now I'm going to turn my volume down, and let's put this into perspective. I'm not going to touch the tone at 127.3, but I'm going to deviate at 2 kilohertz, and look how loud it's getting. I'm going to go 2.5. Now I'm deviating 2.5 kilohertz, and look how loud. I mean, my volume control is barely turned up. I mean, that's borderline annoying.
I think it's past.
Is it past annoying?
That's good. It's good.
Okay.
Good demo.
We want to be have useful information. So I've took it to 400 hertz, so it's not driving everybody nuts. Okay, so we made our point. Now that's plenty loud, and you can see on the scope it's going way off the chart. And if I turn it up, going down the road, listening to the audio, which I'll do, now I'm going to turn off that tone. Can you hear my 127.3?
No, I can't.
It's still there. I can barely pick it up off of my I can barely pick it up. There's my 127. I can still see it. It's still making it to the speaker. So that tells us a couple of things. This particular radio that's over 20 years old, whatever filters are in it are okay, and they're pretty much taking out the PL tones on the output because they're so diminished. I mean, they're just down to where I can measure it, but it's not loud. And another thing is the speaker, the internal speaker on your radio, it's typically small and doesn't have a lot of lower frequency response typically. So if you put a larger, higher quality speaker on your VHF, UHF radio, and you might be able to hear a PL tone. As a matter of fact, what we'll do is this PL tone here with the volume control set where we had it at a normal listening level, let's make a hot PL tone. I just brought it to 11, deviated at a 1.1 kilohertz, okay? That's a hot PL tone. Here's a crazy PL tone at 1400. It's about 3 times louder than it needs to, well, at least 2 times louder than it needs to be. This radio likes to see around 500 or 600. So I'm going to bring it back down to 500 or 600. So there you go. That's what we were talking about. Yes, the human ear, can absolutely hear 100 hertz, 150 hertz. Even as low, you can hear and feel down in the 50 hertz range. You can, you're well aware of it. And between 50 and 100 hertz, that's where a lot of the low frequency energy for music, that makes that music kicking and bumping. And we enjoy it. But we don't need that information in our ham radios. That's just low frequency stuff that eats up power, and eats up bandwidth, and does things of that nature. So stuff much below 100 hertz, I don't have a whole lot of use for in communications purposes. And here we are under standard operation. It's not unusual to see a PL tone of 127.3, 151.1, or even as high as 160. Most of the guys try to keep their PL tones a little lower because the lower the PL tone is, typically not all the time, but typically it's easier to mask on the receiving end. And for those of you who have newer radios with nicer filters and just better electronics, they're filtering that out even better than this radio. I use this one on purpose so that it would show up on the scope and you could hear it a little bit through the speaker. So that's what we're talking about as far as PL tones versus audio information that we actually want to hear, things that hold, our intelligence of our voice. So when we're talking, we understand it. And now we showed that the VHF radio goes far higher in frequency, and at least this radio goes easy to 4 kilohertz. This radio on the bottom here, it didn't even make it, it barely made it to 3 kilohertz. So, and that's something you'll find. A lot of you guys have some of the newer HF radios that are a lot of fun, and you'll find you can go to the receive and you can push the button and you can adjust the bandwidth on your receive and watch it on your scope. There's actually a knee. That knee just goes up and down. And if you're using a program like HDSDR, or you're using one of the SDR receivers that are located throughout the country, they've got different settings. I'm clicking for you. They have different settings so that you can choose your bandwidth on your receive. But where we're typically limited on stock radios is the transmit side. I just recently learned, and I looked it up last week, that the ICOM 7300, its transmit bandwidth, stock from the factory, unless they've changed it recently, is 3 kilohertz. And then it goes all the way down. It goes down to below 50 hertz. It does a very good job. I don't know that we need to be transmitting that low, because that's not doesn't have very intelligible information that low. But then I looked at the Yaesu FTDX 3000. Its stock around 3K for its high frequency limit, but there is a very easy mod. It's a software. It's a push a button, push the power button, hold it. It comes on, and supposedly it magically puts your transmit frequency up into somewhere in the neighborhood of 4 kilohertz. Now, I have not tried that. I just researched it, and I found 2 or 3 individuals that said that that's what happened. So there's a radio that you can expand the transmit audio on. And then there's the folks out there that are doing the enhanced single sideband. They literally take their radios apart, change the filters, do the proper modifications, and their sideband radios have very, very good frequency response. And some of those people they want to make it flat, wide, and clear. And in our case, it was reasonably flat. Wasn't perfect. It's clear in the mid-range, mid-portion of the band, and it rolls off pretty heavily below 100. And by the time you get to 3,000 on this particular radio, it's pretty much gone. So I hope that tonight's visual aids helped get a mental picture of, as your sideband audio frequency increases, often the RF output of that frequency decreases because of the filters in your radio. That way we can put more people using sideband closer together, because if our signals were broadcasting at 4 or 5 kilohertz, so if you had 2 signals that were 5 kilohertz wide, that takes up 10 kilohertz. So in a perfect world with perfect filters, you could put 3 kilohertz wides. No hate mail, because I know that when you're right up against somebody, sometimes some radios won't do that. Some of the newer radios, you can reach up there and adjust one of your slope filters and cut that guy out right below you, or cut the guy out right above you. That's what's the beauty of the newer radios. This radio doesn't have that option. Anyways, that's pretty much it, Jason. I don't have any more. Hopefully everybody enjoyed it and
wow,
nerded out a little bit.
That was a full hour. That was good. That was good stuff. So
that was an hour?
Yeah.
Goodness.
You filled that up. Well, thank you everyone for watching. Hit that like button. It really helps Kevin's ego. I'm kidding.
Oh, yeah.
Anyways, we'll be back next Wednesday Feel free to leave a comment, email us about a question, and we'll see what's in store next week. 7-3, everyone.
Thank you, Mr. Producer.